Hello, we are here for one more lesson of this T-Flex CAD training course, and the topic for today will be the functionality array. This is one operation that T-Flex has with the purpose to create copies of elements in 3D that you already have in your drawing. There are a couple of different possibilities regarding this array. And we will see a couple of examples that will try to show the major possibilities of this function. So to look for the function, we need to go to 3D model menu, and then in this group operations you have array and a couple of different possibilities to execute your array. The first possibility is array by nodes. So the array is to create copies in a certain pattern, and these nodes, among other possibilities, will simply allow you to place the copies of the elements in specific points that you mention. The first thing to show it is which is the source of this array. So I will choose faces, and I will choose this guy here, okay? Then we can select the source point, so I can grab my center, and I can go and select simply my target point. So if I simply say in here, in here, in here, so I will start placing these points to position my elements. There are other different functions that allow you to make variations of this command, but this is simply what you can get with the array by nodes. So let us go back a little and let us see now the linear array, which is one of the basic ideas when we talk about array in any CAD software there is on the market. So array, I will choose again array of faces, so I will choose again my element. Then I have the possibility to say I can choose from the number of copies and the step between each copy, the total length and step, or number of copies and total length. So depending on what we choose here, functions will open in these dialog boxes, okay? I will leave the first one. Then I will apply a couple of numbers around here that I know already. 10. I will say first direction I want to be this one, and the second direction I want to be this one. So now I will say reverse and symmetric, okay. And on the second direction I will give the same data. And also 10 and reverse, and I have this full pattern with a couple of data. Then I can apply some exclusions in this pattern. Let me rotate it a little. Okay. I can choose, this will take a few seconds because this is heavy. So 10 and 10. It will identify, okay, this guy here. I will choose it again and say hold row, hold column. Perfect. I will say another one, in this particular case the opposite, so -10 and -10. It will identify another guy in here. Okay, perfect. So the minus, I will say also whole row, whole column. Okay, good. And I will ask for whole row and whole column in the middle. And okay, that's it. And simply go and do it. It's a little heavy, this model for my computer. So, and you have this kind of pattern, okay? We could do other exclusions, but this is one of the possibilities. Another possibility with still with linear array, I have this arrangement here. I will choose also array of faces, so simply go and choose these elements. Limitations, I will say that this is the limits where I want to place my elements. Now I will say also the directions. So first direction is this one. Second direction, it is this one. And now simply go and say, I had a couple of elements already that I already knew. And these 7. So reverse and copies 21. And in this guy here also 45 and 7 and reverse it and copies. Okay, 21 also. And you see that I can apply my pattern. Let us confirm. And I can apply my pattern if I use that element limitations. Okay, this is also a nice way to apply the array. Now a different model. I had this already done, but let us try to do it again. I can apply a circular array in 3D, array of faces. Okay, you know it already. So simply go and select the elements. So, and one more. Okay, this guy here. And then we can define the axis. So, axis, this one. Okay. You see it's already applying this circular pattern through the axis. I want a little more of these guys. I want also some columns by axis, and I can apply again the axis. The number it can be, for example, I'm not sure, 6. I will say, if I remember, it was around 38 or something like that, and simply apply it, and okay, we get this kind of pattern, which also it is very nice. Another kind of example, we have also this kind of pattern. Let me delete it. No, not this one, sorry, delete this guy. We have another type of array, which is the array by path. And this is a little different because we have this kind of element. We can say not bodies. Yeah, these bodies. Yeah. This body here, which is a fragment, doesn't matter. Then we have the guide curve. I have a curve which is a 3D path. Okay, done. And also I can apply my conditions. If you see, I have some variables defined for the number of these elements. Okay. And I have also another variable that I will use, which is this one here. So if I, at this moment, define, let us try again, okay, this guy here with this pattern, and instead of this, I will say number of copies and step, I will use the big N for the number of copies and the small n for the step. Okay, I get this kind of pattern, which is wrong because this is not turning. But I have all these functions that have similar behavior. This one has a little different from what we need. We get this by path, which maintains the relative position of the element always. And this one makes a twist according to the relative position in the path. So I can say a lot of things in here and simply go and confirm. And basically it is done. It is a very nice function. We can explore this with variables and so on, so it is quite easy. We have also another one prepared, which is a parametric array. It is a little more complex, but we have some explanations about this parametric array of the parametrics connected to this in the lesson where we explain the sweep, the parametric sweep. So we can do this by parametrics. So this element here. In this particular case, we have also some parameters defined, and my apologies, but we need to define this. Let us, instead of doing something quite complex, let us simply edit this to see the parameters. So we have variables defined. So we have a variable for the number of copies, which you can change. And we have driven variables. The number of copy, it is this one, the G. We have this for the step and the rotation that each step will increment. So if we see in parameters, so this is the number of steps. This is the rotation and increment for each step. So basically, let us edit this. So we can say, instead of n, let us say, for example, 25, and probably it will create something a little bigger. So these variables are fixed. Simply, okay, we'll do something more. It is very easy, okay? I think in this particular lesson, it is not very important to see the parametrics in itself, because this is something apart. It's important to understand how the array works, and understanding how the array works, then you have to understand the part of the parameters, okay? And we have this part of the parameters on the sweep where there was some explanation. We have also the theoretical course where there are more explanations, and it is our plan in the end of all these videos to publish some videos only focusing on this topic of the parameters and how to work with them. Okay. So in this topic of the array, these were the things that I was planning to show you. I hope that these examples are clear for your understanding and to focus in the major topics regarding the array. More explanations on the theoretical side, and for sure that if you need some help, please contact us, show us your examples, and put us all your questions in case you need some help on this command.